Hello to all students. In continuing with previous lecture, right, for calculation of inductance of transmission line. So inductance of transmission line can be calculated with the help of calculation of two factors. That is, first we calculate the flux linkage of inside of the conductor. That is the flux linkage of internal flux. And second one is that the flux linkage outside of the conductor, that is the external flux. So here, this slide shows that the inductance of the solid conductor due to the internal flux. It means that we are calculating the flux linkage inside of the conductor. So let us we consider a solid conductor that is the radius r, and the current flowing through is I, as shown in figure. So this is the circular, uniform circular figure of the conductor, solid conductor, in which we have set the radius r and the section x, that and the dx, that is the smallest part, uh, where which we have decided that we have to calculate the internal flux. And here we show the origin. So as we know, the Ampere's law states that the magnetomotive force in ampere turns around any closed path is equal to the net current in amperes enclosed by the path. Mathematically is written as. So here we are applying the Ampere's law, in which MMF, that is a magnetomotive force, which can be described as the ampere strength, that is the N dot I, is equal to the around any closed path, that is the integral part, that is the magnetic field intensity, and the smallest part, that is the ds, are you considered here. You can also describe that it, the dx is equal to I. Here the value of the n is equal to 1. So this is the formula of the Ampere's law, or you can see that this is the formula of the Ampere's law, that is the mmf is equal to integral part of h dot ds. Ds is the smallest part, and h is the magnetic field intensity, and the integral is the closed path, where h is the magnetic field intensity. Okay, that can be measured in ampere turns per meter, and s is the smallest distance along the path. And let us we are considering a tabular element, that is the thickness of dx of the conductor at distance dx from the center of the conductor. So here we are considering a smallest thickness, that is the dx, and we are also considering that that is the hx at a distance x, that is the electric field intensity. It is a constant at all the points, because this is a circular path, and all the parts are divided in equal, and in each part that the electric field intensity must be uniform. And hx is a constant over the constant circular path with the radius of x and the tangent to it. Let the current enclosed by this path is ix, and the current here is the ix, that can we can write here. So here the formula of Ampere's law can be right here. So हम इस फार्मूला को कुछ इस तरीके से भी लिख सकते हैं, अगर हमने h की जगह पे hx रख दिया, और dx की जगह पे जो हमारा डिस्टेंस था उसकी जगह पे अगर हमने dx रख दिया, और I की जगह पे हमने ix रख दिया। सो इंटीग्रल पार्ट जब यहाँ से रिमूव हो जाएगा, और dx की जगह पे जब इंटीग्रल खत्म हो जाएगा, तो डेफिनेटली यहाँ पे 2 पाई x आ जाएगा, क्योंकि हमारा जो सर्कुलर पाथ होता है उसका सर्कमफ्रेंस जो होता है वो बराबर होता है 2 पाई r के। तो ये 2 पाई r जो होता है वो 2 पाई x के बराबर होता है, तो एच एक्स सेम है, इज इक्वल टू आई एक्स। तो यहाँ से हम वी कैन गेट द वैल्यू ऑफ एच एक्स। एच एक्स की वैल्यू जब मिल गई, तो हम बोल सकते हैं कि ये हमारी इलेक्ट्रिक फील्ड इलेक्ट्रोमैग्नेटिक मैग्नेटिक फील्ड इंटेंसिटी की वैल्यू हमें मिल गई यहाँ से। Assuming the current density to be a uniform, there's the current density to be a uniform throughout the cross sectional of the conductor. The current at the radius r. So here the formula of the current density in below section, that is the value of the ix is the current density. So the value of the current density is that ix is equal to 2 pi x square upon 2 pi r square multiply I. This is the formula of the current density. This is already calculated formula. So here you only put the value of the ix in the above formula. So here you can put the value of the ix. So you can get the value of the hx like that. So substitute the value of the ix in the value of the hx. So you can get the value of the hx like that. Another section is that the flux density at the distance x. So the formula of the flux density is equal to Px is equal to mu Hx. This is the BH curve formula. It is the Bx is equal to mu Hx. And what is the value of the mu? Mu is equal to mu non mu r. Another section is that we are calculating the flux around smallest path. So here we are also calculating the flux in a smallest section, that is the phi in a particular section, that is the d phi x is equal to bx dx. So here bx is the flux density. You can say that this is the bx is the flux density. You can put the value of the bx in the formula of the d phi. So here you can put the value of the d phi, substitute the value of the bx in the formula of the d phi. So you can get the value of the d phi like that. The formula of the flux linkage can be written at the x distance can be right here. Though you can get the formula of the flux linkage from the above formula from the equation number 1.9. You can see here. But this is not a formula of the flux linkage. This is only for the smallest part, that is the here you can see that this is the dx d lambda x. So this is only a smallest part. So if you want to calculate the total internal flux linkage, so you have to integral this formula. So we are integral from the zero from the limit from putting the value of the limit from the 0 to r. So we can get the value of the total internal flux, that is equal to the mu I upon 8 pi. So after putting the limit from 0 to r, we can get the value of the total internal flux. Then we have to put the value of the mu r, that is equal to 1, and we have to put the value of the mu naught, that is a constant, that is equal to the 4 pi into 10 power minus 7. We can get the value of the internal flux, that is equal to the I, or you can see that 0.5 multiply with the I into 10 power minus 7 Weber times per meter. But this is formula of the flux linkage. So if you want to calculate the inductance of the conductor due to the internal flux, so you have to put the formula of the, you have to substitute the value of the internal flux to the main formula, that is the formula of the inductance, that is the inductance is equal to flux linkage upon I. So here we have put the value of the flux linkage, and we have to get the we get the value of the inductance, that is equal to the 0.5 into 10 power, or you can say 1 upon 2 into 10 power minus 7 Henry per meter. So this is the calculation of the total internal flux inside of the conductor. If you have any question, you may ask. This is the formula of inductance due to the inside of the flux linkage inside of the conductor. So once I repeat these calculation steps,